let's go see.
I know it's going to be a big install, so I was just trying to get started.
So installing Visual Studio, if you're a PC user, the Mac users already have, I believe, C++ on your machine. If not, you can certainly get it pretty easily, but you won't be using Visual Studio. So to get Visual Studio, you're going to use a site that used to be called DreamSpark. It's now known as Imagine, but our URL is still dreamspark.rose.edu. You're going to go there, you're going to log in, it'll say register, enter our username, which is your Rose State College email address. Does everybody know how to access your Rose State College email? If not, I can post a document about that. It's your Raider email address. It'll be your first name dash last name at raider.rose.edu. That'll be the same thing you enter here. So I'm going to go to dreamspark.rose.edu. I may not have a valid account. We'll find out. I'm clicking sign in because hopefully I have an account. jgthompson@rose.edu. How many times will it let me do this? Okay, register. Click register, enter your username, JG Thompson. Yours will be your first name and last name. That account is already registered this. Fine then. Alrighty. Go back. So to get to your email, I know that there's more than one way to do it, but you can just type in Gmail, sign in, enter your first name dash last name. Your password is, I believe, the same password that you've been using everywhere else, your birth date, but it'll ask you for a new one. And like I said, I really can't fix this for you if something's going wrong. You'll have to talk to Student Services. So you saw what I was doing was I was registering for an account. You just create your account. It said that they sent me something. I'm not seeing it. Okay. Request to reset password. There it is. Thanks. Alrighty, now we need to download Visual Studio once you log in. And of course you're not doing this on your machine here. This is just kind of a really quick walkthrough, and it's on the video. You can go back to it. We see that there's different versions of Visual Studio. It doesn't really matter which one you get as long as it's got C++. And the good news is that they all have C++. So the version of Visual Studio that we have installed on these machines is 2013. Looks like we're kind of out of date. That's okay, really. Howsoever, let's see if that one is available for download. And it is. Visual Studio with Service Pack 1. You might want to go ahead and get that so that the files that you create at home are exactly compatible with the files that you create here. And what do I mean by that? Your C++ code is going to be compatible no matter what. C++ code is, it can be carried from operating system to operating system. It's not supposed to be platform specific unless you're using platform specific libraries, which we will not be using. But the project files that it creates. You know, when you do new project, you start adding things to it. The format of those can change from version, Visual Studio version to version. So you might try getting 2013, and then if that doesn't work, get the 2017 community version or the 2017 professional version. All right. I don't know if I answered your question.
When you get to the install screen, it asks you what you want to install, and there's like desktop development with C++. So I installed that. And
Yeah.
then the other one saying something that works with C#, because I know. I'm
Okay, we don't want C#, but yes, go ahead. So when you install it, if it asks you which tools you want to install, make sure that you select the one that says C++, desktop development with C++. There will be a lot of other offerings too, and if you feel like installing a whole bunch of stuff and looking at it, that's also totally cool. All right, course title. 1173 C++ Programming. Prerequisite. How many have had another programming course? Raise your hand if you've had another programming course. Okay, if you have not, this may be slightly challenging for you. And I'm wondering if you may want to take one of the Introduction to Programming courses instead. But, pressing on, there's a book starting out with C++ from control structures to objects. 8th edition. Having the book is very useful. I won't say it's essential because I don't assign you stuff from the book. I don't say, okay, you need to go and answer problems 4, 5, and 6 from page 389. I'll create my own homework. If I gave you problems out of the book, you'd be able to Google them, you know, and just turn in what other people have done. But anyways, the book is a good idea. That doesn't mean that you have to buy the 8th edition. Going down to the textbook, the Student Union bookstore and buying it's great. But if you want to buy it online and get the 7th edition or whatever, it's almost the same, and you can save yourself some money.
There's a PDF online for like $20.
Well, hey.
I got it for free. I just,
Oh, really?
All right. However you get it, that's fine. I'm not going to tell you to go look for it for free. But if you find it, great. Okay, so anyways, get the book. And even if I don't specifically say, okay, read pages, 20 to 40, keep up. Each time we switch to a new set of PowerPoints, you'll know when we're going to chapter 4 or whatever. Just take that as a cue that you need to read chapter 4. So, upon successful completion of the course. Why is that underlined there? What are you doing, Word? Oh, you want me to put a comma there? Okay. Understand fundamental concepts and general principles of programming. And if you've had other programming courses, you have some of these concepts already. You have a lot of them. If statements, while loops, arrays, stuff like that. But we'll be hitting the C++ specific versions of them. You need to know how to write, compile, run, and debug C++ programs. Debugging means that we use the built-in debugger in order to step through. Is everybody going to be using Windows, or do we have Macs or Linux users here? Windows? Okay, that'll make it a little bit easier because at least when I demonstrate something, it'll be the same thing that you'll see at home. Write programs utilizing logic constructs, selection and repetition. Selection are just if statements and switch statements. Repetition are things like while loops and for loops. Logic constructs, ors and ands and things like that. Utilize array features such as arrays and abstract data types to write software. It all sounds a little bit abstract, so to speak, but we'll press on. Okay, typical grading scale, 90s an A, 80s a B, 70s a C, and so on. The way it's broken down is about a third of your grade is your programming homework. About a third of your grade is what we do in class. And then about a third of your grade are the exams. So if you show up to class every time and you turn in all those in-class assignments, you're going to be, ahead of the curve already. You're going to have 35% of the total score. So if your goal is to make a 75 or a 70 or above, you're already halfway there just by showing up. But you're going to want to do the homework, programming homework too. You need to do at least half of the programming assignments in order to make a C in the class. If you don't turn in if you turn in fewer than half of your programming assignments, you're going to get a C at most, even if the points added up higher. Because if you look at this, I had somebody who came in. This is before I was doing a lot of daily assignments, and they aced the exams. They made 100s on the exams, and then they didn't ever do any homework. And by averaging things out, they almost would have passed the course, but they hadn't done any homework. So, you got to do homework. These dates may need to be a little bit modified. I think July If I have to, yeah. I don't know when the holiday is. Is it the 5th? Do we have the day after the 4th of July off, or are we just skipping having a day off this year because it's not on a weekday? Anyways, the last day to withdraw is July 14th. And the final exam is on July 28th. I will re-upload this with correct information. And that one I do not believe is true this time. So we'll just nuke that one. So grading policy. If you turn in something but it doesn't run, if it has a syntax error, and if you don't know what a syntax error is, you're sure going to see a lot of them in the near future, then you won't get any credit for it. It's like loaning me a car that doesn't run. I'm not going to be able to take it anywhere. I can't take it for a spin if it doesn't compile and run. So you need to correct all the syntax errors before you send it to me. Before you put it in the Dropbox, submit it to the Dropbox to use the correct terms. However, if that doesn't work, what I'm going to do is I'm just going to give you a 1%. You'll see a 1% in your scores, and you'll go, oh, dang, I sure would like to get more points than that. You'll go and read the feedback. I'll say it didn't compile or whatever was wrong with it. Just revise it. Revise it and re-upload it, and you'll get more credit. You'll probably get an A, at least a B. If you get the program up and working, even if it didn't work the first time, you're going to get a pretty good grade on it. If it kind of works, but not really, if it generates the wrong answer, it's supposed to calculate the freezing point of water with a certain amount of salt, and it says that water freezes at 1,000,000 degrees Fahrenheit. Well, I'm going to turn that in anyways. Well, I may give you some credit for it. It does part of what it's supposed to do. It does the input and the output. It just doesn't do the calculation right. You'll probably get partial credit. You might make a C for something that doesn't do everything it's supposed to. But that's kind of at my option, how much partial credit to get. Again, I'm going to, post your grade. You're going to see, oh, I only made a 70 on that. And you go in and you read your feedback, and you'll say, oh, I didn't realize you wanted it to do this. And then you'll fix it and upload it, and you'll get more points. Programming assignments are due 1 week from the day they are assigned. So if I give you any homework today, which I'm going to do, I'd like for you to have it done Sunday night. And that doesn't really sound like a week, so that, that extra day, I don't get harsh on people if they turn it in on Monday rather than Sunday. If you do turn it in by the Sunday night, you get a 5% grade bonus, and those can kind of build up. If you get 10 homework assignments in on time, that's an extra 50 points. That's practically a whole half another assignment. So that's kind of useful. If it's late, then they start getting deductions. 10% for the first week, 20% for the second week, 50%, for being more than 2 weeks late. So keep up on your homework. The real reason why you're doing the homework is not just to get scores, but so that you understand the material. If you're not doing your homework, even if you're sitting in here in class, here's how not to take the course. Don't do this. Don't just come to class and type in the stuff that I'm typing and then have me help you with it, because you make some syntax errors or whatever. Turn that in and then go home and not do the homework or read the book. It's not going to sink in. You're not going to absorb it. So as well as making a bad grade, you're in it hopefully because you actually want to learn the stuff. So to learn the stuff, you need to be doing the assignments. The assignments will be based on what we do in class. Sometimes I'll do, okay, here's something that we did in class. Now I want you to take it home and change it to do this. Yeah. Or it'll be a program that's somewhat similar to the one that we just did in class. I'll never give you homework that we haven't already covered in class. And you must have completed at least 50% of the programming assignments. If there's going to be 8 assignments, you have to do at least 4 of them. The number of assignments, I want you to do them all, just saying. Some people have more trouble motivating themselves to do the homework. If there's a reason that the assignment is late, please let me know about it. If possible, discuss the due date with me beforehand. Say, hey, I had to take my wife to the hospital last night. I couldn't do it. Or, my kid was sick all weekend. Or I had a car wreck. Or, whatever. Had to fly out to North Carolina for a funeral. I totally understand. You just need to let me know. And if you miss a whole bunch of homework, then it's a different deal than if you just miss one. So, I might waive the late fee if you tell me about it. So attendance. I will take attendance every day. You don't get counted off for not showing up. Howsoever, as a general rule, students who attend classes and do not miss many days perform better. That's just a general rule. If it's hard for you to attend class because you have a job that intersects with this time, then you might need to consider what you're going to do about that. You can just watch the videos. If you don't come to class, make sure you watch the videos and turn in the assignments in a timely fashion. If you get behind, you probably won't be able to catch up. Now, this is really important, not just in this class, but in any class. If you do not attend class within the first week of school, any class, you will be dropped from that course with an AW. Obviously, that doesn't apply to you 5. However, we had a 6th person who did not show up today. They will need to be concerned about that. So what happens is you get an AW on your class, on your report card, on your transcript. You're kicked out of the class, and if anybody was giving you money to attend class, they're going to come back and get it from you. So you don't want to miss the first week of course. First 2 weeks for a 16-week course. All right, I don't care if you have tablets or phones or whatever out. Just don't be poking away on Facebook during the class. I know that lectures are kind of boring, but you got to be absorbing at least some of it. Don't do anything on your screen that'll be distracting to the person sitting next to you. We're going to have a lot of code up on the screen that you're going to need to be typing along with. So for those who have chosen to sit in the very last row, if you're making a lot of typos because you can't see it, move up next time. You'll know after today how good your eyes are. Mine are not that good. Keep checking D2L regularly to keep up with the announcements, assignments, and due dates. I do also send email out. Usually if I post an important announcement, I will also post it in email just to make doubly sure you get it. So, things to expect from me. Expect me to give clear instructions for assignments. If the assignment's not clear, call me on it. Ask me about it. To answer questions regarding the assignments and the lectures. I never mind stopping the lecture in order to talk about a question. Absolutely not. I think that's cool. The more questions you'll ask, the more I like you. So, I'm actually serious. The people who give me some feedback and interaction. Those are the people who go on and do well in the other classes because they've learned the material really well.
I think I asked too many questions in Python.
No, I think you asked just enough. I will always give a week notice of assignments and 2 weeks notice of exams. That's really going to be easy since we only have 2 exams in this class. I should have everything graded within a week of submission. I'll try to grade them faster than that. If there are errors in your homework, you won't get full credit, but you can correct and resubmit to get more. All due dates are posted in the Dropbox. If you text me, you get a faster response than email, which reminds me, I would ask that everybody, even if you've had me before, please send me a text. Grab your phone, 405-898-7767. Put your name and CIT1173, the C++ course name. So the reason I ask that y'all do that is so that if I know that I'm going to be late or I need to cancel class for whatever reason, I can send y'all a message out about it. If you know you can't come to class, you can send me a message about it. And probably most importantly, so that if you get stuck while programming, you can always just take a picture of your code and text it to me. And I should be able to give you some good hints right then and there. So those of you who've had me in the classes in the past, a lot of you have taken advantage of that. You'll probably agree that that's a good way to solve problems. And I don't care. Don't worry about texting me at 3:30 at night. I'm probably up, and then if I'm not, I know how to put my phone on mute, so you're not gonna bother me. Academic integrity. Do not cheat. How do you cheat in a programming class? The most common way is to ask somebody else how they did it and then take their code, copy it, and submit it as your own. And if that happens, both of y'all are going to get zeros, which isn't really very fair to the person you borrowed your code from. So don't do that. Other things that people can do is to find code out on the internet that kind of solves the problem and then submit that as your own work. If you do find code on the internet that you want to submit as your own work, you'd better reference it. It's just like an English paper, If you're quoting Wikipedia, which is always a bad idea anyways, then, you got to put where you got your stuff from. Usually my programs are specific enough that I will know, whether you did it yourself or not. If it turns out that you're using techniques that looks like they were invented by a 10-year employee of Google or something like that, I'll know that you didn't write it yourself. Also on the exams are open book, open notes, open PowerPoint. So, that's great news. You do your exams on the computers. If you have the book on PDF or whatever, you could be looking on your tablet, but that kind of offers you some opportunities for cheating. Don't. I had to get on somebody's case for this. They failed an exam last semester because they were using their phone to chat with somebody who wasn't in the class. you know, covertly try to take a picture of their exam, send it to somebody else, you know, and then don't do that. Yeah. Don't ask anybody else for help during the exams. If anybody was sitting next to each other, which nobody is, it's totally okay for y'all to help each other on the in-class assignments, you know, because you're going to be making typos and forgetting parentheses and stuff like that, and the guy next to you may be done. They could help you. Or if you were done early, you could help them. But none of y'all are sitting next to each other. So if you decide that you want to sit next to each other, that'd be cool. Otherwise. But then what happens is people think that, you know, they're programming buddies at that point, and they're gonna do all their homework together too. And you really need to do your own homework. What'll happen is at the first time that happens, you'll at least get a 0 on it. That's the least harsh penalty that'll happen. And it can get kicked to the dean, and things can get really bad from there. So don't do it. Student support services. If you have some kind of disability, if there's something that I can do to help you with the course, let me know. Some people, you know, need to sit in the first 2 rows. Some people need permission in order to take their own recordings. You totally have my permission to record it, you know, that's why I record the lectures myself. Some people need extra time to take exams, you know. Some people have had to have me sit there while they take the exam so that I can explain the questions to them. I will do that, you know, but in order to give you that help and to make it fair for everybody else, you need to provide the documentation concerning why. So you go to the Office of Disability Services. They'll help you fill out a sheet. You'll bring it to me, and I will do whatever it takes in order to help you with the class. With only having 6 people in the class, I should be able to devote a lot of time to each person's work, not like a class with 30 people in it. Okay, the last page, accessing computer resources. The problem with this is that if you can get on D2L, you already know all of this. You know where D2L is and stuff like this, but I could print that out for you if you didn't, if you can't get onto this stuff. So you have my text number, my email address, my office is downstairs. I need to post my office hours. How to log in, how to log in, how to log in. Okay. Alrighty. During 16-week courses, what I usually do is we go over the syllabus, we do a little bit of work, and then we take the rest of the day, and then we hit it hard and heavy the next time. But since every day is effectively a week when you're taking an 8-week course, we really don't have the luxury of doing that. So we're going to press onward and upward. Are there any questions so far? Please? Yes, sir.
When you log in, which one were we supposed to download?
Do a search for Visual Studio 2013. And if you can't find Visual Studio 2013, just grab the 2017 version.
Well, the 2017 one says Visual Studio Community.
Yeah, you can get that. That one's fine. They all have C++ in them, and that's all that really matters. And some people find a C++ that's not made by Microsoft, and that's also cool. It's just that there may be tiny differences in it. If you want to bring your own laptop, that's totally cool. Then you're doing the stuff, yeah, like you. Awesome. Because then you're working on the same platform that you're going to take it home, you know, and work on.
Quick question. Is there any, like, IDEs that you could use for all programming languages? I mean, I know
Eclipse is the most universal one.
Eclipse, okay.
Yeah.
Because, like, for the Intro to Java class, Ken Dewey wants us to use TextPad, but when you download TextPad, it's only like an evaluation version. It's not the actual version. And
Well, if you paid the $20 for it or whatever, it'd make that message go away, but you wouldn't get any extra capability.
Right.
So, yeah, if you're taking Java, some professors want you to do it bare bones, you know, roll up your sleeves and do the work yourself. So you use a text editor like, you know, TextPad or whatever. Other people don't mind if you install NetBeans or Eclipse. Those are the 2 most common Java development tools. Alrighty, so I clicked on Unit 1. What we will see in that Unit 1 folder is a file called boilerplate. This isn't super de-duper important, but every time I start a program in here, I'm going to type the same things over and over and over, which is going to be annoying to those of y'all who are used to Python or whatever, where you don't have to put all this stuff in. This is just stuff that needs to be in every program that we write. So I'm just going to copy it from the boilerplate document and paste it into C++ when I'm ready to go. And we'll learn what all these things mean. It's just to save myself, you know, 45 seconds of typing. That's what that boilerplate document is. The way I got to it is under Content Quick Links. I clicked on Unit 1, or I went to Course Tools, Content, Unit 1. My boilerplate was down there. So over to PowerPoints. They don't have the number there. That's kind of clever. If you hover your mouse over, the pop-up text says which chapter it is. Chapters 1, 2, 3, and 4. Pretty easy. Whenever you click on a PowerPoint and it tries to load it in this little preview pane, go ahead and download it. You will be so much happier. So the first chapter is essentially the same kind of thing that you see in every programming book. Introduction to Computers and Programming. So we're going to kind of fly through this. Why program? What is a computer? A computer is a programmable machine designed to follow instructions. You know, what's the difference between a computer and a calculator? A calculator does math, so it's got silicon in it, and it accepts data and it does display stuff, but it doesn't have instructions that it will follow unless you buy one of the expensive programmable calculators. You buy yourself your TI-99 or whatever they are. But what makes a computer is that you load some instructions in on it, and then it will follow those instructions to do the task that you want. Those instructions are called the program. The programmer is the person who creates the instructions to make the computer perform a task. So just for funsies, what computers look like way back when? Like 1945 or something like that, 1944. Aren't you glad you don't have to carry that in your pocket? That's probably heck. Your microwave probably has more programming capacity than the computers that were made in the 40s.
What were those used for?
They were used for different things. The British did computers for code breaking. The Americans developed computers for weapons development. You know, the atomic bombs took a lot of calculations in order to calculate and making trajectory tables. You know, if you're going to fire this shell and you want to hit that ship that's, 1,200 yards in that direction and with a wind speed of blah, 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 and the shell weighs this much, you need to know, what angle and what kind of propellant to use and stuff like that. So originally computers were used, there were older computers back before electronics. Pascal's calculator. What these were mechanical calculators. Doesn't look much like a calculator, but by the 1800s and stuff like that, science was exploding, and the ability to record information and the need to do calculations was far exceeding the ability of people to do stuff in their head. So like if you're doing astronomy and you're trying to calculate things, or you're trying to keep track of your business, then what people would do is they would have books full like of all the logarithms, logarithm of all these numbers between 1 and 2 million, which means that some poor fool had to calculate all those things and then write them down so that they could be sent to a printer to have that book printed or whatever. So there were tables, books full of tables, and if you wanted to do higher math, you had to go and get the book out, of the library that had the specific values that you were looking at, because you didn't have calculators to do that kind of stuff. So to ease the correction of those tables, because as you can imagine, they would be riddled with errors. Some poor, Oxford, undergrad may have been, a little bit drunk on mead from the night before and not done a very good job. So things like this were invented to do calculations. And I'm going to see if I can give you an example of a calculation. I usually botch this, so let's see if I can do it. And for those of y'all watching the video, you can just tune out for a minute because you're not going to see what I'm doing. So say you have this equation. Say you have a better pen. Maybe we will type. X to the power of 2, and that'll be the last time I use the caret symbol because the caret symbol doesn't work in C++. I'm just doing it here. Plus 3x plus 10. Say that's our equation. And we want to run this through for all the values for 0, 1, 2, 3, 4, 5, and 6, and so on. We wanted to make a book, solving this polynomial, equation, I guess, for a whole bunch of values. So what is x squared plus 3x plus 10 if it's 0? Well, 0 squared plus 0 plus 10, that's equals to 10. What if we do it for 1? 1 squared is 1, plus 3 is 4, plus 10 is 14. What about 2? 2 is 4 plus 6 is 20. Let's do one more. 3 squared is 9, plus another 9 is 18. It's equal to 28. So then we look at it and we wonder if there's a cheating shortcut. What's the difference between 10 and 14? This is 4 more than the one above it. All right, big deal. This one's 6 above it. Oh, that one's 8 above it. So very quickly you could decide that even without doing a calculation, the answer to that one would be, 10. Because it's 10 higher than the one before. And then the next one would be 12 higher than it was before. And the next one would be 14 higher than it was before. And let's see if that's actually true. 6 squared is 36, plus 3 times 6, which is 18. That's getting botched in my head. 46. Yeah, I think that's right. So you saw that we were able to come up with a pattern that let us essentially do this without actually having to do the math. Looks like a mechanical process. It looks like something that can be done with wheels, repeated over and over and over. And that's what Pascal's calculator and some other guys came out with the same kind of idea. Those would be the first calculators. But they weren't really computers because they didn't have a way to store instructions. And that's when a guy named Babbage came out, or tried to invent, a monstrous thing like this. And why was it so large? Because it had all the components of a modern computer. Y'all have heard the term steampunk, probably. The first steampunk book was called The Difference Engine, based on the idea of what if computers had been invented in the 1800s and there were computer hackers, in the 1800s and stuff like that. So the idea is that in order to have a computer, you have to have memory that you can read and write to. You have to have a place where your program could be stored. And you have to have some way of getting output, like a printer or something. And you have to have some way of getting input into it. Really, to be a useful computer, it has to have those 4 components. It has to have, memory to hold data. It has to have a place to hold a program. It has to have some way of getting input into it. So this thing, people had already invented punch cards, believe it or not, before computers. But the punch cards controlled looms for weaving complex patterns in cloth. So he took the idea that you could enter data into it via punch cards. And you could enter programs into it via punch cards. And then you would set it off for running, and it would print all the tables that you needed to do with whatever program that you had written. And he spent a huge amount of the government's money, Britain's money, building this thing. Got very close to getting it done, but then they shut him down. So he invented an even grander one. That's the way inventors go, which he never got to finish. But people have actually built them now. This is one probably on the floor of the main headquarters of IBM or whatever. So computers have been around for a long time, even before there were electronics. Vacuum tubes could hold data. How do they hold data? Well, the state of the vacuum tube, whether it's completely lit, might be a maximal number on it. If it's completely unlit, it's a 0. If it can contain partial stages of brightness, it represents intermediate numbers between there. So you could have memory in the form of vacuum tubes, which were just forms of light bulbs. One of the weirdest forms of RAM, of computer memory, was using a cathode ray tube, just like a TV monitor. You would have a screen, and there would be dots on the screen. And if the dots were lit, then that was a 1. If the dots weren't lit, it was a 0. And so all your data was stored on a cathode ray tube, which is really bizarre. The cathode ray tube wasn't being used for display, it was being used as a data storage technique. Another kind of memory device was tubes of mercury. And you could send a little sound pulse down them. And if that sound pulse was in the tube of mercury, there would be a receiver at one end and a little amplifier at the other one. If sound was going through the mercury, then that was supposed to represent one form of data, and if there was no sound going through it, that was another one. Drop your computer and you have mercury spill all over the floor, and you have to call, the Environmental Protection Agency. So 40s.
Then you just sweep it up, or whatever.
Pardon me?
Not then, you just sweep it up.
Yeah, sweep it in. Yeah, play with it. I remember playing with raw mercury, and I always wondered what it did to me. So 40s was pretty much the invention of the electronic computers, the real invention of them. There's a movie about von Neumann, who was one of the key guys in computer science. Von Neumann movie. I haven't even seen the movie, but I want to. The Imitation Game. If you ever see The Imitation Game available for viewing on your favorite viewing service, you might watch it if you're interested in computer history. I need to. It may turn out to be a horrible movie and I shouldn't have recommended it, but we'll take that risk. Alrighty, something else I want to show you. Early input devices. We know what a trackball is. Graphic designers who don't like to move their wrists that much get trackballs so that they don't get carpal tunnel. However, how about that one? Now that's a trackball. That's a bowling ball in there. If you think your eyes are deceiving you, that you're not. So why would you have such a thing? Because you wanted the ability to move a cursor around the screen besides just having up, down, and left and right arrow keys. And this would give you, the ability to move your cursor all over the screen. And why would that be important if you were writing some air traffic control kind of thing or missile tracking software, and you wanted to be able to move a cursor, in arcs on the screen? You need something like that. So I don't remember when the trackball was invented. We could probably find out. 1952. So you could see that a mouse is essentially just a trackball turned upside down, or at least they were until until laser mice were used. However, the first mouse was not quite that sophisticated. Here's what the first mouse looked like. You can't really tell from this picture, but it had 2 wheels. It had a up and down wheel and a left and right wheel, which if you can imagine using it to move it around would kind of be annoying. You'd have to tilt it one way to get that one wheel in action to move it up and down, and then you have to tilt it another way in order to get the horizontal motion. So you couldn't do the diagonal lines with a mouse as it was back then. But of course they were improved pretty quickly. And that was invented during the 60s.
When did they take the idea to combine the two? Like for the trackball mouse or whatever?
I don't know exactly when they would have done that, but the improvements would have come pretty quickly. I'm sure that by the 70s, effectively the first mouse had already been invented. Maybe even by the late 60s. Let's here we go. Guy at Stanford drove the development of the first mice. But along with the mouse, he also liked this gadget. If it looks like piano keys, that's what it is. So, you'd play 3 fingers if you wanted one command to happen. You'd play 2 fingers on here if you wanted some other command to happen, play sequences of notes or whatever. Obviously, that didn't take off.
Just like in Dota, okay.
Yeah, yeah. So it's pretty cool. But I guess if he was really cool, he could have had organ pedals, down there along at the bottom. And then his 3-button mouse. So this was done under the auspices of Professor Douglas Engelbart, who is pretty much considered the father of modern programming, modern computer interfaces, because he came up with the idea of, well, having multiple people edit the document at the same time, having windows on the screen that you can move around, all of that kind of stuff. Before then, all you had is, green letters on a black background or words on paper, So he's an interesting guy to read about. That's about enough, except I want to show you like the first home computers. Oh gosh, my brain just totally froze. You'd order them from the back of Popular Science or Popular Mechanics and build them yourselves. Ugh. I mean, these are light years more sophisticated than what I'm trying to show you. There we go. The Altair 880, or 8800, considered by many to be the first home computer. Okay, if we zoom in on this thing, there's a couple things to notice about it. It's a lousy picture. There's no keyboard on this guy. You didn't get a keyboard when you ordered this computer. There's no TV output on it. The way you program data into it is you flip switches and then you press another switch, and that would write a number out into its memory. And then you flip some more switches and you press a button and it writes the next number into its memory. And then when you're ready to run the program, you set the switches in a certain way, and then it runs the program and it displays its output in the form of little glowing LEDs, just red dots, whether they're lit or not. And yet people thought that was pretty cool. Wow, I have my own computer.
What was the point? What were they used for?
Hardly anything. Do you remember you used to be able to buy those, 101 science experiments things where that they were just essentially for teaching. But then people figured out ways to hook them up to your TV set, because they were honest to goodness computers. They actually did have, a chip in them and stuff like that, and they did have memory. But so after you bought this thing, then you could buy a keyboard and wire it in, and then you could wire it to your television, and then you actually had a computer. But it wasn't until the Apples and the Ataris and the stuff like that came out that mere mortals, rather than
That nerd.
yeah, then the super nerds in Silicon Valley could use them. Imagine if you were a data entry person and all you were allowed to do was to flip switches. That'd be really boring. It'd be hard to play Call of Duty that way. All right, these slides are like, do we even care anymore? Nowadays we have more power on our wristwatches and all this stuff, and we don't have hard drives and things like that. But pretty much we know that if you're writing a program, it's going to be accepting input. Input is stuff that goes into the program. They're showing keyboards and cameras and touchpads and stuff like that as the input. And then output will be displayed. The kind of output could be text output. It could be, you're sending stuff to the speaker, that kind. You're sending stuff to the printer, that kind of stuff. And then you have what's known as secondary storage. Up until recently, all your second storage was hard drives, pretty much. Nowadays, you buy laptops that don't have hard drives in them, and you buy, phones without hard drives in them because of flash RAM, solid state memory. Solid state memory is cooler than hard drives, no pun intended, although they do run in a lower temperature, because there are no moving parts in them. They are faster. The way a hard drive works is that you have all these ones and zeros written on a magnetic platter or a whole stack of platters, and you have to move that head into a new place and then read a string of digits, and then that head's got to move somewhere else on the hard drive and read in a series of digits. And even though modern hard drives are really fast, your computer is almost infinitely faster, So anytime it had to go to the hard disk, would slow your program down dramatically. Then again, reading from the hard disk was still infinitely faster than accessing data from the internet. And that's the slowest thing we can do nowadays. All right. I'm just going to say, hey, y'all, read this PowerPoint. Read chapter 1. Because what I want us to do is to actually launch Visual Studio and write a program. So click on the Start circle, or however you launch programs. Type in Visual and launch whichever version of Visual Studio you installed. Now to write a program, we first have to create a project. Microsoft sometimes calls it a project, sometimes they call it a solution. In different words for the same thing inside the same program, and I'll show you what I mean. If I go over here and do File, New, Project, that's what I want to do. And you have to do this for each new program you write. File, New, Project. Then you may come up with a million different choices here. We want C++. So under templates, I'm going to open templates. I'm going to choose Visual C++, and I'm going to choose...
Oh, you can program a lot of different stuff in this.
Right.
Okay.
Click on C++, and it's none of these choices here, actually. It is empty project, which means when it comes up, it's not going to have a single thing put into it. We have to start from scratch. That's what that boilerplate is for.
So what would be the difference between, well, I mean, I know the difference, but if you were just to do a new file?
If you do a new file, you won't be able to compile it.
Oh, okay.
Yeah.
That's probably the problem I was having last time I ever touched Visual
Yeah.
Studio. Why is this not working? Okay.
So, like with TextPad, you can crank up a new Java file, and you can start typing stuff away in it, and you're ready to compile. But with Visual Studio, you actually have to build the whole package. If you use something else, you're still going to have to do something similar. Behind the scenes, it creates something called a make file. And a make file is part of the project that tells it what files it needs to compile in order to get it to work. The term compile, we'll talk more about. Okay, so choose empty project. Give it a name. If you didn't give it a name, that's okay. So all I did is type hello as my name. You can pick where your projects get saved with this browse button. If you don't, it's going to be saved in, well, mine's going into users, local admin, documents, Visual Studio. That's kind of nasty. I'm going to go and click browse, go to my desktop, make a new folder called C++ projects. Then I'm going to go in there and select that folder. I just do that to make it easy to spot. Then I click OK, and it creates an empty project. So when I was babbling about it, calling it a project in certain places and solution in other places, we did file new project, but then if we look over here, we see something called the Solution Explorer. The Solution Explorer lets you see all the files in your project. We don't have any files, but we will. Most of the stuff that we use is going to go in the source files directory. So we're going to need to right-click on that and do Add, New Item. And is everybody at this point? I don't want to rush ahead and, okay. I better. All right, so what I did, thank you, is I right-clicked on source files, did add existing item, new item. I typed in a file name, hello.cpp. I clicked add, and it came up with this document. So I'm going to try to remember the boilerplate from memory. Include IOStream. The include statement, this is what's known as a preprocessor directive. We don't really care what that term means for the very first day. But it brings in this library. It's the same as like an import statement in some languages. So there's a library called IOStream. That stands for Input Output Stream. Stream is kind of a weird term, but that just means that it's going to be accepting a series of characters, like what somebody might type, or it's going to be displaying a series of characters, to a screen. All right. What was the next line?
Include string.
Okay. This one's not necessary for every program we write, but it's nice to have it as part of the boilerplate. The string class lets us store non-numeric data. If you have numbers like 1, 2, 3, or 4.5, 6, 7, 8, 9, those go into different kinds of variables, known as integers or floating point variables. But if you have a word, like your name or a date or something like that, you need to store it in a string. And that brings in the string library so that we can use the string class to create string variables. And I'm going to be using words over and over before I've actually defined them, so just kind of nod and go, yeah, I'll let you get away with that for a little while, Prof. Okay, so what's next?
It's using namespace std.
Yeah, using namespace std.
Because like in other languages and stuff, like Python and stuff, you don't really, if you want to use strings and stuff, you don't have to import from like a little library.
Exactly.
Why do you have to do that with C++?
Well, these bring in libraries of stuff that were designed to make the language easier to use. By default, there are things in the language that will hold string data, but they're not very easy to use. Classes make string data easier to use, and so there's a string class. Otherwise, you would be storing your data in an array where every letter is its own item in the array, and you wouldn't have all those niceties that we were taking advantage of in Python to get the length of the, or to add two strings together or stuff like that.
Gotcha.
So yeah, this is way more primitive than Python. You'll find in what comes built in. Not nearly so much comes built in. I won't say that doesn't make it lesser. You can do awesome stuff. Almost every program that you use on Windows is written in C++. Every game you play on your Xbox or PlayStation is written in C++.
Class to learn then?
Pardon me?
Is this a good base programming class to learn then?
Yeah, you need to know C++. It's a really good basic programming language. Yeah, y'all need help?
Mine's acting like it's a text file, so and nothing's highlighting.
We'll talk about what namespace does as well really soon. We'll keep bouncing back against it. Okay, so every program we write in C++ has to have a main function.
Ours says int main. I don't know if that.
It doesn't matter whether it's an int or void. Just to make it look like our boilerplate, I'm going to make it int. Okay. What this would do is it would allow us to return a number back to the operating system after the program was done.
Oh, okay.
So this is a function. A function has a name, and then it's got parentheses. And it's got a word before it, which is a data type. And then after the function name in the parentheses, there will be a pair of curly braces. And our code that is inside that function goes into curly braces. That's an L, by the way, not a 1. So end line, right. So we have written a program. After we build it, after we compile it, what happens is when you compile it, C++ goes out and turns it into what's known as an object file. And then those object files are linked together to make an executable. And once that executable is made, you don't have to have C++ on the computer in order to run it. Unlike Python, where if you give somebody a Python program, they have to have Python in order to run it. Same with Java. But a C++ will create an executable that's tailored to that specific operating system. That's why, though, if you give somebody a C++ executable, they're not going to be able to run it on their Mac or Linux or whatever unless they have some kind of emulation software that handles it. So it builds all that, it links it all together, and then when the operating system runs it, it looks for main. If it doesn't have a main, it's not going to run. So if you want to do a thorough rebuild, you can just go to Build, Rebuild Solution. That rebuilds absolutely everything. I tend to do that just because I like seeing absolutely everything get done. And it should say down here, 1 succeeded, 0 failed, and that it made a file. It tells me the path to that file. That's the file that I'm going to run. If I come up here and I choose debug, and either start debugging or start without debugging, it's going to run the program. And then we will see something very annoying. It's going to flicker and close the window because I forgot to type something under here. There was one more line of code that's in the boilerplate that I didn't put. But let's run it and watch. Ooh, that was satisfying. Let's run it again. Yay. It's closing a window when it's done. So there are more than one way to handle this. One of the easiest ways is if you're programming on Windows, you can make a system call to the pause command. What is the pause command? Well, a pause command was originally written for people who were writing command line programs. If you launch open the command window, CMD, the terminal, and you type pause, it just says press any key to continue. So what this does is it tells the operating system to use the command line processor to run the pause command, which is actually going to do what we want it to do. It's going to say press any key to continue. Build it again, rebuild solution, run it again. You don't have to choose debug, start debugging, or debug, start without debugging. You can just whale on this green arrow right there and run. Okay, it says hello world, press any key to continue.
Are comments in C++ with this, the forward slashes?
Yeah.
Okay, so that's the reason ours didn't run it, because if you copy from the boilerplate, it has the C out is commented out.
Oh, okay.
Because if you run it, it just says press enter.
So yeah, if you looked at the boilerplate, it had that. Those two things comment out the line of code. It removes it from it. It's still there in the code, but the compiler ignores it, so it's no longer part of the program. So if you just copied the boilerplate and you weren't typing it in by hand like me, then when you ran it, it didn't do anything except say press any key to continue. So let's get rid of those slashes, and then it'll work.
What is, if it tells you the project is out of date?
Means that you've made a change that hasn't been saved. It needs to save it, and then it needs to recompile
Oh,
it.
so that's what the rebuild solution every
Right.
time. Okay, gotcha.
Right. So, what are the double slashes used for? At the top of every program you write, please put your name, the date, and some kind of description of what this is. First program. Yay. What you use comments for is to describe what the program is doing. All right, so we have written a program. It displayed a message on the screen. Now that's not terribly exciting. Let's make it do something a little bit more interesting. Let's ask for a number. Ask for two numbers and then multiply them. So what this cout arrow business does is, this stands for console output, which in this case is a window. And these are called the stream operators. This sends a stream of characters to the console, to the screen. There is another form of console command called cin, which reads from the screen. So we're going to use those. Cout enter x colon. Now since I didn't put ENDL, it's not going to go to the next line. It's going to leave the cursor right there. Now we need a variable to read into. So float x, comma, or semicolon, float y, semicolon. We've just created two variables, and we have said what type of data they are. We're going to learn that there's a lot of different types of data, so that there's a lot of different types that you can use instead of that word float, including words like int or string or long, things like that. What float stands for is floating point, which is a number that can have a decimal point in it. The other popular numeric type is integer. Integers cannot have decimal points in them, so I chose float in case the user wants to type in 1.3 rather than just 1. So really we should have declared our variables before we started asking for input. So I'm going to cut this line and paste it. I tend to use the keyboard almost exclusively rather than using the mouse much, so I'm going to tell you how I'm doing this. Some people go, wow, how'd you do that so fast? Hold the shift key and the down arrow and it highlights a line. Then hit Control X. That cuts. Then the cursor key down a couple of times. Control V for paste. At one time, Windows did not have Control Z, X, C, and V, and if you wanted to paste, you had to hit Shift Insert. If you wanted to cut, I don't remember if it was Shift Delete or what. Anyways, it's nice to have them all down there. Okay, so here we go. Enter X, and now we want to read some data into the X variable. So what this says is display some output. And those words are what's going to be displayed on the screen. Now let the user type in some data and store it into the X variable. A variable is a place in memory where this data can be stored. We can create as many variables as we need. Now let's also read in Y. So C out, arrow, arrow, double quotes. They have to be double quotes. Some languages let you mix them. This one does not. Enter Y, colon, semicolon. Now let's read that in. So CIN greater than Y.
I've noticed one thing about Visual Studio is how it has like the autocomplete when you have when you're like typing in a string, I guess. But how do you actually make it autocomplete? Because
That's a good question. It seems annoying. What is an example of an autocomplete? Okay, so like you type F and it pops up this list here. Use the down arrow to choose the one you want, and then the enter key.
Okay.
Should get it.
But when like say like do like another C out
C out.
and then just type something. Or just type something in there. Or no, like as in like you were actually displaying something to the screen. In your string.
So it's displaying a lot of different things here. Those aren't that useful at this point.
Oh no, I meant like if you like go ahead and put your comma, or not your comma, yeah. So like now it has an open, or it has end quote as well.
Right.
Like if you type something in, it still wants you to put in the end quote, I guess is what I'm saying. Because like if you hit enter, what do? You just
Oh,
Just arrow.
you're right.
Okay, arrow.
I would use the
Okay.
cursor to skip past
okay,
it.
I see what you're saying. I'm just
Right.
saying it kind of doesn't make any sense. Because
Right.
you
Yeah.
Still have to. I just typed it in.
Well, so many programmers, when they're entering quotes, they enter two quotes and then they back up one and start typing into it. And so the developers of Visual Studio decided that if you type in one quote, it's going to go ahead and fill in the second quote. What's that?
How'd you do that so fast?
Oh, I used the delete button. Each
Oh
deletion.
no, like to do the double. You did double quotes twice.
2004.
No, I typed in one quote and it filled in the other.
Oh, I'm sorry. I just
Yeah.
pointed that out.
Yeah. Okay, so now we have input X, we have input Y. Let's get our answer. Float Z is equal to X times Y. And now let's tell them the result. C out. Now when I say arrow, it's kind of context specific. If it's output, you need to use less than signs. If it's input, you have to use greater than signs. You just have to kind of remember that if you're displaying output, the arrows are going to C out because they're going to the screen. If you're getting input, the input's coming from the input keyboard, so you use the other arrows. Because I will not always remember to say less than, or greater than, greater than. Quite often I'm just going to say arrow, and you need to remember which one to use. And hopefully I won't mess it up too much, but I guarantee that I will at least once. I'll type the arrows the wrong way. Okay, so the product is space, end quote, less than, Z, less than, ENDL. So now I'm going to rebuild the solution. If I had a syntax error, it would show up. I'll give you an example of a syntax error. Say I forget my semicolon on one of these lines. Well, it's underlining this. And here's what drives people crazy. I know that's right, dude. I did not misspell the word float. That's easy. Well, the problem is on the line above it. So if you absolutely cannot figure out what's wrong with your line, look on the line above it and see if there's something wrong. But if I had not fixed that, then when I tried to build it, if I go to build, rebuild solution, then it pops up an error list down here. 3 errors. It says float should be preceded by a semicolon. Well, that's actually a pretty good error message compared to some of the errors that we've seen in other programming courses. And then it says IntelliSense expected a semicolon. Z is undefined. It may display 7,000 errors here, but usually you only have like 3 or 4 to correct, and then all 7,000 of those go away. You know, it's showing 3 errors here, but really there's only one problem, which is that missing semicolon. So if I click on that one, and I see float should have been preceded by a semicolon, I go, oh, I missed my semicolon. Now I'm good to go. And so as we go through this class, in the early days, y'all may be making lots of typos. And I will come back there and help you spot them and fix them. Okay, let's run it. This program is out of date. Do I want to build it? Yes, I do. And as a matter of fact, I'm going to say do not show this dialog again and just build it every dang time. Okay, hello world, enter X, 10. Enter Y, 20. The product is 200. So the program worked. Let's try to break it. Enter X. Well, let's see if it accepts decimal points. 40.1. Enter Y, 0.01. Nope, that didn't break it. What I mean by break is see if we can give some data to it that'll cause it to malfunction. And we can. It's pretty easy. If we type in a word rather than a number, it's not going to know what to do. Enter X. No, I don't want to. All right. Well, it did something.
Wow.
It did something with it. I can't say how it came to that answer.
And Y, it says enter Y, and it already told you the product. It didn't even let you enter Y.
Yeah. Yeah, so it did not behave in any way that we would expect. It'd be interesting to print out X and to print out Y so that we knew what it contained in that case. But at least it didn't blow up with a syntax error, but it certainly did, I mean, with a runtime error, but it certainly did not give us any good input. Excuse me, any good output. Okay, so what is a program? A program is a sequence of instructions. What does C++ do? C++ takes that sequence of instructions and it compiles it, meaning it turns it into machine language. And that machine language is just a series of zeros and ones, binary data that's stored in a file called an object file. And then a linker comes along and links the object file to make an executable file out of it. And you usually don't have to worry about that stuff as a beginning programmer because that happens behind the scenes. We don't go out and find the object file, but we could. Go to Solution Explorer, right-click on the line that says Solution, one project, and do Open Folder and File Explorer. And if you look, there's an SLN file, that stands for Solutions File. There's an SDF file, I'm not even sure what that is. And then there's a directory called Hello. Well, I already was in one called Hello, but it has the same name underneath it. And then there's one called Debug. So if I double click on Hello, or whatever you called your project, then you see your CPP file, hello.cpp. And then there's some other things in there, which I can't really say what they are. Open with, I'm going to use Notepad to try to open one of those.
I think one's a project file. This one's, and it says that, on mine it says that one's a project file and the other one's the project filters file.
Yeah. So I'm using a text editor to look at it, and there it is. It's a great big XML document that contains information about the project. When you turn in your homework, you only have to give me the CPP file. I can grade it based on the CPP file. Howsoever, if you want to give this to me in a form that I could open it up in Visual Studio inside the editor and be able to compile it for myself, or if you want to be able to give it to somebody else, or if you want to take it home and work on it, you can't just copy the CPP file. And I'll show you what I mean. I'm making a copy of that CPP file and I'm going to paste it on the desktop. I'll get back to it in a minute. If you want to give me the entire folder structure, which would be required to give me the entire project rather than just that program file, what you want to do is you want to close Visual Studio. Before you close Visual Studio, absolutely do make sure that you have done the Open Folder and File Explorer. The reason I say that is just so that you know where your project file is. Okay, so I'm going to close Visual Studio. The reason I'm doing that is to make sure absolutely everything is saved. Then I'm going to go out to my projects directory, right-click on it, and do Send to Compressed File. Compressed zipped folder. There are other ways to compress things into a folder. If you like 7-zip, that's cool. If you have another zip program, you like WinRARs or whatever, you can do that. But you select that folder inside your projects folder, and you zip it, and it creates a zip file. That's what you have to send me if I'm going to open the whole thing. I only want the CPP file. But if you're going to take this stuff home, you're going to want to get the entire folder, and that's an easy way to do it. Here's what happens if you don't get the entire folder. Say you just emailed yourself hello.cpp. You go, okay, cool. Here's my program. Awesome. Now I'm going to run it. Start debugging. That's grayed out. How can I run it? How can I build it? I can't do anything with it. The problem is it's not inside a project. You will have to create a new project and put this file in as part of the project in order to get it to work.
So when we send you this, we just look at our syntax and create it.
What I do is I have an existing project. I copy the code out of your CPP and I paste it, and that's the fastest way for me to run through them all.
Okay.
Yeah.
So you just run everybody's projects.
Right. Yeah.
Is there a reason that that Visual Studio makes you make a project? I mean, I know most like gigantic IDEs like that make you make a project, but is there like a specific reason that they make you?
I guess it's just that it doesn't know anything about what language it was expecting, if there's some kind of framework involved. Because you saw how many different choices there were when we were creating the project.
Like inter-language projects where it could have programming in C++ and
Yes,
Python
yes
or
you
something
can.
too, or-
Yes, you can, and I am not really familiar with how to do that, but absolutely you can.
Okay.
Especially if you're doing .NET development, you'll be using C#, but you can use other .NET compliant languages as well
That's C++.
to access them. Yeah. So I have the CPP file. I'm going to do new project, empty project, just like we did before. This is if I didn't know that I had that zip file somewhere. And then I'm going to do add existing item. And I'm going to go and find that file where I pasted it on the desktop. Now at last I can actually run it.
So what's the difference between source files and resource files and header files?
A source file is your source code, your CPP file. It's got all your C++ code in it. A header file is a special kind of source code file that you can use to share code between source code files. We'll talk more about it. If we have some definitions that we want to be shared between more than one of these CPP files, then we would put that in a header file.
What would be the point of having more than one source file?
A complicated project could have thousands.
Okay.
Yeah. A big game or an application like Word or whatever is going to have so many different files in
What are
it.
the resource files? Just as another-
Resource files are things like graphics and sounds and stuff like that.
Oh, okay. So if you want to store like a background or something.
Exactly.
so it's-
Right. Right.
okay. And then you call it up in your source file.
Yeah. Yeah.
Okay.
Right. I clicked on resource source files, add new item, resource,
So you can just
a
store images,
bitmap.
like call it a certain name and then call it in the.
I'm going to try to get us to the point where we can do a little bit of visual programming. For the first half of the class, at least, I'm sure that we're going to be doing the command line programming when we wouldn't be using resources at all. All right. Are you in this class, or are you using the room because it's cool?
Oh no, I'm in this class. I I'm sorry I'm late.
Okay, what you're going to want to do is you're going to need to watch the video. I record all the lecture videos, and you'll need to follow along with the video so that you can upload what we did today. Each class will have a tutorial component where I am typing stuff in and people are typing along with me, or I'll give you a handout, but nowadays it's usually me typing up here. And we've already done that. And so class is going to be about over, but you'll still get credit for it if you go home and watch the video and upload it. So do you know how to let me pause the la-di-da-di-da.
One last but slightly important question. Is there any way you can get your output to show in Visual Studio, or does it always have to run in the command line?
It always runs in the command line as far as I know,
Okay.
which isn't, you get used to it.
Well, yeah, I know. I'll get used to it. I'm just
Yeah.
saying, because you know how like Python has its shell.
Right,
thing.
and Java does the same thing if you're using NetBeans. It displays its output, you know, inside of NetBeans. Okay, so in order to upload this into the Dropbox, if you haven't done this before, what you do is you go to Dropbox inside of our class. You click on the folder name. It says Submit Files. You have to pick a file, Add File. And you can either click on Upload and move to the directory in which your file was in, or if you did that bit where you did Open Folder, you know, then you can go in, find the CPP file, and give it to me. If you're not seeing file extensions, if you don't see hello.cpp, if you just see hello, I really strongly recommend you turn extensions on. The way you do that on Windows 7, can't believe they're still using 7. I mean, I love it, but you know, y'all are on 10. Yeah. So anyways, what you do is one of these options. There will be somewhere a folder and search options in your dialog. And you're going to want to go to View, and there's one of these says Hidden Files, no, not Hidden Files, Hide Extensions for Known File Types. By default, that is clicked, so you don't see .cpp as opposed to .h as opposed to .exe. And all that's very useful information. So find out how to go into your folder options, and it's different for, you know, every version of Windows. Deselect that thing that says Hide Extensions for known file types, and then you'll see the letters hello.cpp. Why do you need that? Because there could be 3 or 4 different files in here, all with the first name of hello, you know, but then with different extensions.
All the C++ files have that little icon though, I think.
Right, right. You can eyeball the icon. It's got the 2 pluses next to it. Very good point. And I double-clicked it, which is not what I wanted it to do. I actually was going to try to drag and drop it. Be all fancy. So here we go. You can drag it in there and add it that way, or you can just, you know, do it the other way. We click Add File. You go and you pick your file. You have to move, you know, maneuver to the correct directory. What I would do is I would drag your projects folder as one of your favorites so that you can get to it easily. There's my hello.cpp file. Click Submit. And if everything worked great, you should see a message that says success, confirmation email sent successfully. And then when you go back to the Dropbox, you should see a number here, probably 1. You probably only submitted 1 file. If you don't see a number there, that means I didn't get it. Not a huge deal for, you know, in-class assignments because you can come back and submit it the next time. But you never know if your machine's going to get replaced while you're not in here. If you come in Wednesday and a machine has died and they put a new one in there, and so all your work on it is gone. Definitely upload everything that you do every day, and also I'd recommend you just get a flash drive and copy stuff to it. Or you could just work from your flash drive, but then eventually you're going to lose it. It's a no-win situation. Anyways, you just have to figure out how to make your backup copies. I wish that they let us, you know, like log into Google Drive so that all of our work was backed up, you know, to the cloud while we did it. All right, so your homework is going to be to install C++, or if you're not going to, and then once you've done that, create a Hello World program and run it. And then either just give me that CPP file or write a Word document or a Google Doc or a text document or whatever saying, I installed Visual Studio and ran a program on it. That's all it takes. And what we want to do is we want to make this due next Sunday. This Sunday.
Is this the only C++ class that's offered here? Or do you guys do higher level C++?
There are higher level C++ classes, and there's a C# class as well. The next groovy version of C++, what is it called? Windows programming?
the
Yeah,
Windows
it is
programming.
offered in the spring, not in the fall. So there's going to be a little bit of a break. And so if this seems too elementary and you already know this stuff, then I apologize. I don't have a
Oh,
new
no,
class I can
was
throw
just-
you
I was
at.
just
But
wondering, 'cause
definitely.
I'm really interested in like the visual programming and stuff
Yeah.
like you're talking about.
So you'll definitely want to enroll in the visual programming for Windows class. I wish it was offered in the fall though. I hope you can hang out and take it in the spring when it comes up. And in the meantime, I would take Java in the fall because we do a lot of the visual programming, the Windows-based programming in there.
I know. I wish I had you for Java. I have Dewey online right now.
Well, dude's cool.
Well, I know, but I've had you for all my programming classes.
Yeah.
So. Plus the whole. Do you do the whole coding style invention or convention for Java too? How you're supposed to?
I post a document, but I don't harp on it much. I need to see his. Give me a copy of his file. I'd be
Okay.
curious to see it. All right, gang.